issues, delays, extra cost, rework, and blame. I'm Vlada, a framing detailer at New Vision Agency, and if you think you can risk your schedule for missed posts or framing errors, think again. I'll show you how we prevent it. Today, I'll walk you through the 6 most common framing issues we catch in the model and show how proper coordination helps avoid them in the field. Real issues that a BIM model catches. You'd be surprised how often framing issues slip through. I'm talking about jobs where everything looked buttoned up. Architectural drawings, structural plans, even elevations with callouts everywhere. But then you open the framing model and realize there is a beam with no post, a tub that doesn't fit, or a hold-down sitting right where the door is supposed to be. These aren't rookie mistakes. They happen because coordination was done without proper trade collaboration, and no one looked at how things actually come together in 3D. So let's take a look at the common issues I've seen on almost every job and learn how to catch them before they cause chaos in the field. And if you stay till the end, I'll tell you how exactly we can help you save your project and your budget. Missed or extra wood posts. One of the most common issues I see is missing or misplaced wood posts. Beams are clearly shown on the drawings, but the posts or columns that are supposed to support them, sometimes they are missing completely. And if the building sequence is to install walls first and joist second, you don't realize the problem until the beam shows up on the side. And there is nothing underneath to support it. Now you're scrambling, cutting into finished walls, adding posts after framing is already installed, losing time, money, and a lot of patience. Another common issue, a beam at the roof level has a column drawn only at the roof, but that column was supposed to continue through every floor below. If you miss that during coordination, you are not just fixing one level, you are chasing a structural mistake throughout the entire building. And trust me, when the field crew has to stop everything, cut into framed walls, and rework around new posts, it's not just frustrating. It's expensive, but completely avoidable with proper coordination. No space for header. Another common issue, windows or doors framed too high, way too close to the top of the wall, and nobody checked if there's enough room left for a structural header above the opening. So when it's time to frame, you realize there's literally no space to install the structural elements you need. No header equals no support equals no inspection pass. At that point, you have 2 unfortunate options. Either shrink the rough opening or lower the window or door to make space, both of which trigger redesigns, extra detailing, and sometimes even a trip back to the architect for reapproval. It's a small mistake on paper, but a major headache once materials are already out. Panels are built and crews are standing there asking what to do. Holdowns clashing with MEPF. Holdowns are critical for structural stability, but when they're placed without coordination with MEPF systems, it creates major problems. It happens more often than you think. Structural rods land exactly where a duct needs to run. Holddown hardware blocks the space needed for plumbing stacks or large electrical conduit, and no one realizes it until the mechanical, plumbing, or electrical crews are already on site. At that point, you're stuck with 2 poor options. Either reroute critical systems, which can throw off ceiling heights, soffits, and fire ratings, or shift structural elements, which means redesigns, new calculations, and delays in inspections. All of it because structural and MEPF layouts were developed separately, without full coordination in the model. Fixing this in the field is not only hard and expensive, but can even lead to failed inspections. No space for compressed studs. And speaking of hold-downs, sometimes the structural drawings show the shear wall layout and the rod locations, but they don't account for the collector studs that actually carry the load. As an example, we had a project where the foreman laid out all of the TDS rods exactly according to the structural drawings. Everything seemed fine, until they started framing. Turns out there was no space left for the collector studs. Doors and windows started clashing with the rods. Some openings had no room for proper jambs, and moving the hold-down rods wasn't an option, because it would mean tearing them out of the concrete. As a result, massive rework. Doors and windows had to shift. our team had to jump back in, re-coordinate the entire wall framing layout to make everything fit, after the material was already on site. It wasn't just frustrating, it was expensive, messy, and 100% preventable with early coordination. At least, we've expanded our already vast experience with one more detail that we'll definitely not miss again. And if you'd rather not learn from your own mistakes, but do everything right from the start by relying on the experience of an already seasoned team, reach out to us using the link in description, and let's keep this problem out of the field. And now we're coming to one of the most common disconnects between designs and real-world installations. Tubs, doors, and elevators don't always fit. Drawings often use typical dimensions for tubs, doors, and elevator shafts, and in the early stages that makes sense. But once actual submittals come in, those typicals don't always match the real equipment. We've seen tubs that physically couldn't slide into place because the framing was too tight, elevators that requires a few extra inches for clearance, but the shaft was already built. Even doors where the rough opening didn't account for casing or swing, and no one made a mistake. It's just that the real sizes come in after framing was already done. But when we integrate submittals directly into the model, these conflicts are easy to catch early. We adjust rough openings before framing starts, not during install. We avoid last-minute field changes, and framing stays aligned with what's actually being delivered. It's all about closing the gap between design assumptions and real field conditions. MEPF running through shear walls. Shear wall resists seismic and wind loads. They are critical. Yet we've seen MEPF systems routed through them without reinforcement or engineering approval. This isn't a minor mistake. It compromises structural integrity, triggers redesigns, and can even lead to project shutdowns. In proper coordination, shear walls are protected. If penetrations are needed, they are engineered correctly, not left for the field to figure out. How VDC and BIM solve this? So far, we've covered that kind of issues happen without proper coordination. Now, let's talk about preventing these issues. It's not a guesswork. We rely on a clear set of tools and methods that help us catch problems early and make sure framing works in the way it's supposed to. 3D model and issue log. We don't catch issues by scanning PDFs. We build the full framing layout in 3D, down to every stud, post, and hold down. That models become the foundation for everything else. We run clash checks, coordinate with architectural and MEPF layouts, and log every problem that shows up. Nothing is missed. Nothing gets buried in emails. The 3D model helps us understand what can actually be built. When we place all the wood posts, we immediately see where they don't fit, or where they float in without support from below. Because when we model, we are thinking about the full structure of the building, not just one level at a time. That's how we catch problems a foreman would normally find in the field, like realizing there is a beam at the roof, but no posts carrying it through the lower levels. Same with Holdowns. We don't just place rods, we model every collector stud and blocking member, and then we can see exactly where the rods need to go. This helps us avoid the usual clashes with doors, tubs, MEP, and more. And when submittals come in, there is no need to scramble to adjust the framing in the field. We update the model and keep everything accurate before anything gets built. Because the modeling is done not for design intent, but for real conditions. And that's where the issue log comes in. Every problem we detect in the model, whether it's structural, architectural, MEP related, or just a missing dimension, goes into the log. But it's not just a list. Our issue log is a full coordination record. Each item includes a clear description, screenshots, and exact location. It's connected to relevant sheets, submittals, or RFIs. Each issue is assigned, tracked, and updated as coordination progresses. This is how we maintain transparency across the team and make sure every issue is resolved before prefab or install. It's important to note, the issue log doesn't have to look the same on every project. We align it with different workflows depending on the team and the tool. Sometimes it's a live issue schedule that can be sorted by discipline, location, or status. Sometimes it's a PDF plan set with markups so you can visually spot the issue right where it happens. In other cases, we use platforms like ACC, where issues are created directly on the drawings and navigated within the full project workspace. There is a huge variety of ways to track design, structural, and MEPF coordination items. But what really matters is not how we track, but what we catch. Prevents field rework. At the end of the day, everything we do comes down to one shared goal: preventing rework in the field. Because when framing isn't coordinated, rework is guaranteed. You're cutting into finished walls, moving doors, adjusting hold-downs on site, calling for last-minute approvals while the crew is standing there waiting. But when everything is modeled, checked, and coordinated ahead of time, the field team builds with confidence. They are not chasing fixes, but following a plan that actually works. We're not talking about avoiding one or two mistakes. We're talking about hundreds of small issues that never make it to the job site because they were solved early in the model. So the real benefits of proper framing coordinations are predictability, efficiency, and no less importantly, peace of mind. I hope now you will stop relying on field crews to find framing issues, because now you know that coordination isn't just a bonus. It's the difference between building clean and costly rework under pressure. So if you're ready to start building more efficiently, feel free to reach out for a more detailed consultation using the link in description. Let's build it right the first time. And if you found this video useful or at least entertaining, leave a like, subscribe if you haven't yet, and share your experience down in the comments.